Yes. Yeah, let's first do a recap of last class. And the last class we were discussing about IP address. Before that, we discussed about the MAC address. What's a MAC address? Now we got a little bit better idea of IP address. Typically, both are required to send or receive data from one computer or one device to another device. Unlike MAC address, IP address is temporary, which means if you move to one network to another network, for example, your Wi-Fi to, let's say, phone internet, then your IP address will change. So IP address are only used when you want to connect to a network. So that's what we understood. Network means a bunch of devices that we already know. Yeah, mostly one computer, one IP address. I mean, an IP address, one IP at a time. Typically, when you're at home, if you're using Wi-Fi, IP address is allocated by your router. Your router typically gives you IP address if you're typically in a home environment, mostly. Then we discussed about different variations. We have IPv4, which has 32-bit address, something like this, 32 bits. In decimal, you donate like this, or in binary, it's like this. 8 bits, 32 bits total. The range is, if all are zeros, the range is 0. If all are ones, it's 255. So in a way, the IP address ranges from 0000 to all the way to 255, 255, 255, 255. So these many combinations are possible. Like you can see 0, 1, 2, 3. And so on. And finally 255, then 1, 0, 1, 2, and so on. Total roughly to 4.3 billion is possible. Like these are some of the IP addresses we saw from our computer. Computer typically have two IP address. I mean, we have like concept of public IP and private IP. So in a way, you can have only one public IP, one private IP, but in a way you can count as two IPs. Yeah, you can't have two private IPs, two public IPs. So public IP is mostly for network because we have a limited IPs. Yeah, I think you just have to mute. Yeah. So that's why we create private IP, since we have only few number of IP addresses, but we have billions of devices outside. So we cannot give each IP to each device. That's why we create private IP and so on. In a way, typical computer, a modern typical computer can have four IPs: IPv4 private IP, IPv4 public IP, IPv6 private IP, and IPv6 public IP. Like usually, the internet service provider assigns that, but depends on the thing. Let's say. So that's the recap. That's what the idea is. Now today we'll address a small thing like how data passes from one device to another device. Today we'll see in more detail another device. With the help of Cisco Packet Tracer, I will see more. Let's see. Today we'll mostly focus on this, how data passes from one device to another device, technically. Let's see. So yeah, I would use Cisco Packet Tracer. Okay. So let's say I'll take one computer, this one. I will give an IP address. So you can give an IP address by going to config, desktop, IP configuration. You can give any IP address. So I'll just give roughly like this. You can give anything, it doesn't matter. One dot, I would give 2. Then click on it. The subnet mask, we will see what this means later. Just click on it, you will get like this by default. That's it. Save it. Automatically save. Just close. Similarly, you can take another computer, double click, desktop, ipconfig 92.168.1.3. Click here, automatically comes. Similar, I'll take one more, one last, this one. 192.168.1.4. See? So to give you some names, let's give some names. This is 4. This is 3. And this is 2. Yeah, just to give you like something like that. Now we know that all 3 devices can be connected via hub, or sorry, switch. You can use hub also, but switch, let's use switch, please. Switch does not need any IP address. Maybe that's the point. I'll note it down. Switch does not need IP address. But switch will have, you can see, double click. You can see switch have ports, we call, like these are ports. You can see these are ports. Port 1, 2, 3, 4, all these ports. Switches have ports, let's say. Switches have ports. You can connect any computer to that port only. Typically via wire, let's say like this. So I'll do automatic connection. Click here, click here. When I click on it, it automatically connects to one of these things. One of these things in real life. But since we have a simulation, you cannot see it. But in real life, yes, one of these things will be connected. You can even see it. Let's say path is net 1. Let's see, is that connected or not? Okay, let me come back. Maybe. Switch have basic settings. Let's see. This is physical config. Let's see any config required. No need. No need. Yeah, no need. So let's connect other computers also. Here, from here. Okay, so enable all 3 are connected. Wires are connected at least. So we have to give some time until this turns green. So let's wait a bit. So meanwhile, I'll just see any things I can explain here. All are by default. You don't need to change anything. All are by default. Yeah, you can give names. You can change. That's okay. Um, yeah, nothing much to tell. Yeah, nothing much to tell actually. Unlike router, you have to turn on the power and everything, but here it's okay, straightforward. Okay. Okay, all are green. Now everything is fine. So now I'll tell you, I want to send a message from 2 to 3. Let's see how the message passes. I'll just simply click this message. Click here. Then I click here. So you can see successful here down. But I'll do simulation. So click on simulation here. Somewhere here. Just check. Simulation. I'll just play it slowly. But before I play it, you can see there are a bunch of filters here. You just have disable all, edit, only see this. I see. Okay, now play. Yeah, you can see the message goes here first. The message will go here. The second, we can inspect it for each message. Then reply. Reply from here back to reply here. Okay. So you get the message delivered, reply also received. Now let's see each message. So here you can see each message. You can see the first message started here from PC0. The PC0 to switch comes, something like this. Then switch to PC1. You can see that's a second. Then PC1 to switch. Then switch to PC0 back. Now, so I'll tell you how the message goes. So I told you each switch contains ports like these ports. Uh, these ports. These we call ports. So port 1, port 2, port 3, port 4, port 5, and so on. So let's say, for our example, the switch has 4 ports. Let's say, example, port 1, I'll just give like this, port 2, port 3, port 4. Let's say. So when we connect to our computer, example, this computer to one of these ports, you will have to link it in a way like, hey, this MAC address is connected to this switch port number 1. So for example, let's see what is MAC address of first computer. Let's see, double click, IP config. You can see MAC address is this one. No, that is IPv6. Just a second, here only. Configure. Is MAC address. See here only. It will be here only. Here. So this is the year. So I'll just note it down. Computer 1 has MAC address this. Computer 2 has, let's see, computer 2 MAC address. This is computer 2. IP config. Desktop. Where is that? Copy. That is computer 2, then computer 3. So this is computer 3. Double click. Config. Let's take the name. Yeah. Let's take IP address also for our reference. Let's take this IP address is this IP address is 3, this IP address is 2. Yeah. So all these computers have, this is the MAC address, this is the IP address, MAC address, IP address, MAC address, IP address. So this is basic data, nothing. Now, what happens is, if we go back to here, close it. So when you send a message from, let's say, ear to ear, you typically will tell, let's say you are the sender. You are the sender, let's say. That's a computer 1. You want to send a message to computer 2. So what you do is, you will give your MAC, you will tell your MAC address first, which is we call sender MAC address, let's say. Then you will add the receiver MAC address also. let's say receiver MAC address. Okay. Yeah, that's a receiver MAC address. Let's say. Plus you have your message, whatever the message is. That's your idea. So you require these three things. One is your sender MAC address, then receiver MAC address, then the message, like mostly. So as a sender, if you want to send a message, you need these three things minimum. Of course, you have your own sender MAC ID. You have message, of course. But how do you get this receiver MAC address? So that's the question, unless you know them. So initially, when they are connected, nothing is known. Like, I mean, if we go there, initially nothing is known. But what switch does is switch will learn the MAC address and tell each people like. So I'll tell you. So there is a protocol called ARP. We call address resolution protocol. Sorry. So what this does is, let's take an example. Let's say you have one computer, you have another computer. This computer has its own MAC address, IP address. This computer has its own MAC address, IP address. But this computer doesn't know anything about this computer MAC address because MAC address is physical. It's within the computer. It's very hard to get somebody's MAC address. So what this does is this will send something called ARP request, they call. So I'll tell you. ARP request. ARP request means, I'll tell you. It's like this. Hey, I want to know MAC address of this IP, whatever IP you have. Example 192.168.1. Let's say give 3. This is what request is. So computer 1, this will request, or let's take this only. Let's say computer 1, this one, will send a ARP request to everybody. Like, hey, I have this IP address. Please tell me your MAC address. So that is what they call ARP request. So this one, ARP request contains few things. One is sender MAC, sender IP, sender MAC, let's say. ARP request doesn't have receiver MAC, but ARP request receiver IP, they can have. That's it. So ARP request like this. Hey, I want to know the MAC address of this IP address. And that ARP request is broadcasted to all. Broadcast means everybody gets it, like, which means the request, let's say this is the ARP request. The ARP request comes to hub as for switch. Switch will send to this computer, switch will send to this computer. Switch will send to any computer which is connected, like. So let's say switch ARP request coming. This computer IP address is not what exactly this is looking for. So this computer will reject it. Hey, this is not my IP address, so I'm not the right receiver. But this computer will be like, hey, this is my IP only. Take my MAC address. So that is what they call ARP reply. So I'll just try mention it. ARP reply. So ARP reply comes from the receiver. Receiver like, hey, you're looking for me only. Me only. Or in other words, this is my IP only. This is my IP you're looking for. Take, here is my MAC address. Here is my MAC address. Simple like that. So it will send this MAC address, whatever the MAC address is. So now that ARP reply from here goes here, Here it goes here. Now this computer will know the MAC address of this computer. So that's how each computer gets to know other computer MAC addresses. Initially, nobody knows anything. This computer doesn't know about this. This computer doesn't know about this or any other computer. Right? Let's add one more computer also. Let's say this example. Disconnect also. Connect, connect. I'll also give one IP very fast. Let's give 5. Yeah. Yeah. So initially, no computer knows nothing about any other computer. But when this computer wants to send a message to this computer, it has to know its MAC address. Without MAC address, you cannot send data. Data is not received. Data is received because of the MAC address only, because of the that physical thing. So this computer doesn't know its MAC address. So obviously it can send the data initially. So that's why it will send a ARP request initially, first time only, one time task. First, it will send a ARP request saying that, hey, who has this IP? And that request will be forwarded to here, here, here. So obviously this computer will reject it. Hey, this is not my IP you're looking for. This computer also will be rejected, will reject like, hey, this is not my IP you're looking for. But this computer is like, hey, you're looking for me only. Take my MAC address. So that comes here, that comes here. We'll see in action. So let's clear everything. Here I apply filter, read filter. You can see there is a ARP, ARP. I'll enable, I'll disable the ICMP. Now I create a message. Let's say message. Say I want to send here. Let's say I send it to this. Now let me play it. You see here what happening. So first ARP request comes here. The ARP request is forwarded to all 3 computers. But obviously this computer is not what this computer is looking for. But this computer is what exactly is looking for. So these two reject it. Like, hey, this is not my thing. Then this computer will send the message saying that, hey, you're looking for me only, take my MAC address. And that MAC address will be passed here. You can even see in the messages, let's say here, switch to, you can see, first PC0 to switch 0. This is PC0, this is switch 0. Then switch 0 to PC1, switch 0 to PC2, switch 0 to PC3. So same message is forwarded to this, this. You can click on one thing. I will broadcast. Something like that. And finally, these two ignore. Of course, these two will ignore these. Like, hey, this is not mine. But this will respond because that is what this computer is looking for. That's why you get the response. Yeah, so that's the idea of how data is, how 2 computers or more than 2 computers are connected, pass the data across all. Now, once it knows its ARP request, once it knows its destination, the next time you don't need to send ARP request again. ARP request only you send first time when you don't know the sender or receiver MAC address. But if you know receiver MAC address, you don't need ARP request most. So anyway, I'll just tell you one thing here. If you right click here, let's say here, not right click, but let's go and search here. Click here. You will something like ARP table. You see something this. You can see ARP table. You can see table is IP address, hardware, interface. Interface means connection with past Ethernet. You can see this IP address, which is, let's see which one, this one. This is the MAC address. this IP address, this is the MAC address. So in a way, this computer stores the data of this computer IP address and MAC address, this computer IP address and MAC address in its table. That table we call ARP table. ARP table. Yeah. Yeah, so that's the table. You can see simple table. It's like this. First is IP address, MAC address. I think these two are enough. That's IP address. We'll type it. We'll type this only. So IP address 3, IP address 3 has this MAC address. So let's I'll just copy paste. Which is exactly here also same. 3 E0, 3 E0, same only. Something like this. Similarly, IP4 has this. You can see 1.4 B2, 1.4 B2. So that is this computer ARP table. Let's see this computer ARP table. Okay, you can see this computer ARP table, you don't have right now, no data is present because maybe no request is sent first time data. Let's check this computer ARP table. Okay, only one has, which is 2 IP2, which is this, and hardware MAC address is this. So let's take this computer. This computer also has one, which is IP2 MAC address. So in a way, these two computers know MAC address, IP address of this computer. This computer knows MAC address, IP address of these two computers. But this computer doesn't know anything, like nothing so far. But you can make it work by sending a message. Let's see. First, let's check its ARP table. You can see nothing is there. But let me send a message. Let's say I want to send a message from year to, let's say, year. Okay. I will pay it. ARP request comes because first time the ARP request is distributed. These two will reject it like, hey, this is not mine, but this will accept. It will send its. Now you see this is updated in real time. I think I have to do this, but anyway. Yeah, you can see. So let's do one more message also. I want to send this time from year to year. Send. Again, ARP request goes. It goes everybody. But these two will reject it. Hey, this is not mine. This will apply back. You will see changed here. You will see it. Just wait. You can see. List. Let's do one more last message from year to year. Play. So you can see now these two will reject. This will accept. One entry will be added here. Yeah, you can see one entry. So in a way, this computer knows everything about these three computers. Now, next time, I'll close everything. Next time, if you want to send a message from one computer to, let's say, this computer, it does not need to use ARP request anymore. So let's see, just delete everything. Send a message from here to, let's say, here. Let's see, it's in progress. Just wait. You can, okay, message you have to, no message is successful, but you cannot see it because ICMP disabled. So this is enabled. Message forms. The message will directly reach there because it already knows about this computer. Reply will come, reply also will go back. That's it. Yeah, so that's how systems get to know each other. Uh, Initially, when you connect cables, no device will know anything about anybody. But by sending some messages to each other, simple messages, you will learn about them. You will learn about their MAC address, uh, so that next time onwards you can communicate without any problems. Like, but first time you want to know their details like MAC address, you create a ARP request, you send it to all. Like, hey, tell me your MAC address. So whoever has the right receiver that you sent, they will reply, hey, this is my MAC address. And that's how you get to know it. In a way, you can also see it by your computer. You go to terminal or command prompt in your you can say ARP, sorry, ARP hyphen A. Type it, enter. You can see this is ARP table. I can say this is one IP. This IP has this MAC address. Anyway, this device has this MAC address. There is another computer here. This has probably my phone, I guess, uh, or my own IP address, maybe. My own IP address, actually. This one. Let me test it. Wi-Fi details. Yeah, this is my, okay, mine is 102. Maybe this is my phone or something. I have another computer, so it's not turned on, but let's see. Ah, so this is another computer address. So this is 255. This is a broadcast address. It's not a computer. 255 is a broadcast. We'll see that later, maybe. You can only use 1 to 254. You will not use 0 and 255. They are reserved for their own purposes. 255 is a broadcast. Uh, yeah, but this is the main device. This is a router, probably. You can also check your computer. I'm pretty sure uh, you can receive like MAC address and everything. Yeah, so that's the idea of the ARP table, ARP request, ARP reply, ARP protocol, address resolution protocol. Yeah, any questions, uh, anything confusing? Uh, See, maybe some things you'll have to practice it. Obviously, you're looking at me doing it will be okay, but the minute you start practicing only like this, you will understand better actually. You can track each thing and see what happens. Of course, I'm showing everything as it's working, but when you do, you will make mistakes. Like you will not assign IP address and directly send a message. That's a mistake. That doesn't go. For example, if I connect here, but I want to send a message from here to, let's say here, we'll send it. Okay, first I have to delete previous, delete. Here, send. Message itself is failed, you see, because this computer doesn't have, we did not add IP address. So yeah, these mistakes you make actually. So that's why maybe you just have to practice it by taking these. All three, four computers have IP addresses, so they're working fine. Okay, how can we check ARP in our systems and how to identify which addresses belongs to it? See, when you say your system has only one network, which is mostly your Wi-Fi. Example, if you're at home. If you're on Windows, you can go to command. You can simply type ARP-A. You will see these devices. So this is again, these three devices. You can say I just learned another one. Okay, this is a different one. Mhm. Okay. So I have only few only. So yeah, you can just type this command. Maybe you will Windows. I'll just confirm it just once. ARP A works on Linux, I'm sure. Windows, let's see, Windows works. Windows maybe slight difference command might be there. Let me check. Okay, Windows also same command. Just type this